The tail unit, which is sometimes called the empennage, comes in many different designs. It can be conventional, T-tail, H-tail, or V-tail. The tail unit provides, in most cases, the longitudinal and directional stability and control. A small number of aircraft have their longitudinal stability and control provided by foreplanes or canards, as seen here on the Rutten Cozy. The horizontal surfaces, which are known as the tailplane or horizontal stabilizer, provide longitudinal stability by generating upwards or downwards forces as required. Longitudinal control is provided by either the elevators or the moving tailplane, depending on design. For instance, the Boeing 747 uses elevators for control and the tailplane for pitch trim, whilst on the TriStar the roles are reversed, the tailplane being used for control and the elevators for trimming. The vertical surfaces, the vertical stabilizer or fin, generate sideways forces as required to provide stability about the normal axis. Directional control is provided by the rudder. The operation of these flying controls is fully covered in the Flight Controls series of lessons. Both the tailplane and the fin are subject to similar, but smaller bending and torsional stresses as the wing. Structurally, the tail unit components are generally smaller versions of the wings, in that they use spars, ribs, stringers, and skin in their construction. On some aircraft, they may also contain sealed compartments for fuel storage. They are also constructed of the same basic materials as the wings. Usually, aluminium alloys are used, with composites filled with honeycomb structures or high-density expanding foam sometimes being used for control surfaces to provide greater stiffness at low weight. Aerodynamic flutter is the rapid and uncontrolled oscillation of a flight control, or the surface to which it's attached, which occurs as a result of an unbalanced surface. A full aerodynamic explanation can be found in the Principles of Flight series of lessons. Flutter is caused by the interaction of aerodynamic torsion and bending forces, inertial forces, and the elastic properties of the surface or structure. It can lead to catastrophic failure of the structure. Flutter must not occur within the normal flight operating envelope of the aircraft. Flutter can be prevented by mass balancing control surfaces to alter the moment of inertia of the surface and therefore the period of vibration. This can be achieved by positioning balance weights forward of the control surface hinge line to move the control surface center of gravity closer to the hinge line. Flutter of the wings can be prevented by using the engines as mass balance. This is done by mounting them on pylons forward of the wing leading edge. The fact that an aircraft is poorly maintained, particularly in respect to excessive control surface backlash or flexibility, may mean that flutter will occur at speeds below the limit airspeed,